All right, so we're going to find the particular solution, or we're going to solve the differential equation, same question, if you actually have the second derivative. So on the video before, I just had the first derivative. So check this one out. So I have the second derivative. So if I integrate the second derivative, because it gets me backwards, it finds me the first derivative. And if I integrate the first derivative, I get the function. So every question we've done so far, we've been given the first derivative, we have integrated and gotten the function. Now I have the second derivative. All right, now I don't even have the first derivative. I just have an initial condition on the first derivative. And I have an initial condition on the function itself. So the only function I have is the second derivative. See, there's no number filled in there, but these will have numbers filled in. All right, so let me take the second derivative. If I take the second derivative, which is 2, and I integrate 2 with respect to x, I will find the first derivative. So when I integrate 2 with respect to x, I get 2x plus some constant. Now, I need to know what the c value is, and I can find the c value because I know when I integrated the second derivative, I found the first derivative right here. I have the general solution for the first derivative, but I need the particular solution so that I can integrate it again and find the original function. So I'm going to use this initial condition right here. This says when I plug in 2 into the first derivative, I get 5. So I'm going to take my first derivative. I'm going to plug in 2. So when I plug in 2, I will get 5. So 2 times 2 is 4 plus c equals 5. So my c value has to equal 1. So that means that my first derivative is, but the particular solution of my first derivative, I'll write it down here, (2x plus 1). All right, now I want to find the function itself. So to find the function itself, I have to integrate again to find the function itself. So let's move this over here. So I'm going to integrate the first derivative. So I'm going to integrate 2x plus 1 with respect to x. All right, so this one has 2 pieces, so I have to break it up. Integrating 2x with respect to x, I get 2x, add 1 to the exponent and divide by it, plus some constant. Integrating 1 with respect to x, I get x plus some constant. So the general solution is 2 divided by 2 is 1, so x squared plus x plus some constant. All right, so now I'm going to go back to the original set of initial conditions. It told me that if I take 2 and I plug it into the function, I will get 10. So I'm going to do that. I'm going to take my general form of my first derivative, of my original function. That's the general. I'm going to plug in 2 in the x, and I'm going to set it equal to 10. Again, because it says it right here. When I plug in 2, I get 10 out. When I plug in 2, I get 10 out. All right, so this is 4 plus 2. So 6 plus c equals 10. So c equals 4. So when I solve the differential equation, I find out that my final answer, my f of x, is equal to x squared plus x plus 4. So my final answer here is x squared plus x plus 4. That is my particular solution for the original given initial conditions.